Okay, let's talk about this photo, because it's got everyone buzzing. NASA's Perseverance rover, chilling on Mars like it's no big deal, casually snapped a picture of the night sky. But what showed up in that image? That's where things get weird. It's this bright, stretched out, glowing object, just streaking through the Martian sky. And immediately people were like, wait, is that a comet? Others, nah man, that's a mothership. And honestly, the debate hasn't stopped since. One of the most jaw-dropping moments came when NASA's Perseverance rover captured a blurry spot in the sky. That faint smudge? It's where scientists expected 3I Atlas to appear. It was taken just one day before its closest approach to Mars, yet the object showed up only as a dim mark next to a cluster of stars around magnitude 8. What's striking is that the image didn't reflect a brilliant tail or a glowing nucleus. It was almost ghost-like, barely distinguishable from the background stars. The tail was essentially invisible at that moment. The unexpected behavior of sunlight around the object already hints that this isn't your everyday comet. But that image was only the beginning of the oddities we'd uncover. To understand what's weird about 3I/ATLAS, we need to talk polarization, how light waves align and scatter. Normally, when sunlight hits dust or ice around a comet, scattered light has certain predictable polarization signatures. Many comets show negative polarization at small phase angles, when the sun, comet, and observer are nearly aligned, and positive polarization at larger angles. Yet with 3I/ATLAS, astronomers observed something extreme. Its negative polarization is deeper and narrower than anything recorded before. In fact, it dips to about negative 2.7% at a phase angle close to 7 degrees, a combination unseen in all previously known comets and asteroids. This suggests the dust grains around Atlas could be highly irregular, rough, odd in shape, and perhaps made of materials we don't often see in solar system comets. The light waves are aligning in unexpected ways, almost as if the comet's environment is shaking up what we thought we understood. Transition. So if the way light bends and scatters is strange, what does that tell us about the comet's makeup? By studying polarization, scientists can infer the size, roughness, and composition of dust grains. With 3I/ATLAS, the extreme negative polarization pushes us to think this material is not like typical comet dust. The particles may be much more jagged or comprised of rare compounds. Adding to the mystery, observations from the James Webb Space Telescope, JWST, revealed a coma dominated by carbon dioxide, CO2. The ratio of CO2 to water is among the highest ever seen in a comet. In other words, the gas environment around Atlas leans heavily towards CO2 outgassing, something unusual for comets this far out. Meanwhile, spectroscopic studies have detected faint emissions like CN, cyanide, but 3I/ATLAS seems heavily depleted in carbon chain compounds compared to many comets. This chemical fingerprint, strong in CO2 but weak in typical organic gases, suggests the comet may have formed under very different conditions than those in our solar system. Also, there are new models of anti-tails, tails pointing sunward, not away, emerging. A recent paper argues that the anti-tail in Atlas might come from anisotropic sublimation, ice grains on certain sides surviving longer, producing structure toward the sun. So between weird dust, exotic gases, and unconventional tail behavior, the composition itself is raising red flags. The question, do these differences point to a strange origin or something more deliberate? One of the strangest things about 3I/ATLAS is how it handles motion. Comets that emit gas generally experience rocket effects. As gas pushes outward, the comet's trajectory shifts ever so slightly. But with Atlas, even while shedding gas, its path remains remarkably unaffected. That suggests its nucleus is extraordinarily massive, or dense, resisting the nudges of gas emissions. In fact, recent estimates suggest its mass might exceed 33 billion tons, a value orders of magnitude higher than typical comet expectations. Because if it loses mass and still holds trajectory, it must be holding itself together with an immense gravitational or structural strength. Then there's its trajectory alignment. Unlike most interstellar objects, Atlas' path is aligned nearly with the ecliptic plane, the same plane the planets orbit in, within just approximately 5 degrees. That's highly unusual for something arriving from between the stars. Even more wildly, the timing of its passage near Mars, Venus, and Jupiter seems too coincidental. Some argue this alignment is no accident, and here's a chilling twist. The arrival direction of Atlas is within approximately 9 degrees of the direction of the famous WOW signal captured in 1977. Some see that as a strange resonance. Others see it as wild coincidence. Finally, in dividing up anomalies, Professor Avi Loeb split them into 2 categories. Those possibly explained with more data, size, tail shape, polarization, and those he considers perhaps forever puzzling, the ecliptic alignment, the perfect planetary passes, the direction near the WOW signal. Transition. Given all of these oddities, scientists are asking, is this simply a bizarre comet, or something else entirely? Let's tread carefully now, because we're entering speculation territory. But given how many anomalies stack up, it's worth exploring without jumping to conclusions. Many researchers still lean toward a natural origin, a comet born in a distant star system, thrown into interstellar space, and now passing through ours. The hyperbolic trajectory, the presence of volatile gas and dust, many comet-like behaviors, all point in that direction. Yet some, notably Avi Loeb, argue that the combination of anomalies, the huge mass resisting acceleration, the ecliptic alignment, the timing, the trajectory near the WOW signal, is so unlikely to occur naturally that we should at least entertain the idea of artificial or engineered origin. He frames it as a pedagogical exercise, not a claim. Critics push back hard. They point out that extraordinary claims demand extraordinary evidence. They argue that invoking alien tech distracts from the genuine scientific investigation. NASA itself has dismissed speculative theories and emphasized that behaves like a comet in all observable ways. A middle ground. Maybe Atlas is a new class of interstellar body, not a typical comet, but not necessarily an alien probe either. Maybe in some rare corner of the galaxy, conditions produced objects unlike anything we've seen, and this is almost one of them. Whatever its nature, ATLAS presses us to expand our definitions, question assumptions, and remain humble in the face of cosmic mysteries. While Perseverance gave us that initial blurry shot, the closest approach was actually best imaged by Mars orbiters. But due to technical and funding constraints, those images may take time to release. Meanwhile, Earth's motion now means Atlas is harder to observe from our side. The glare of stars, the angle, and the increasing distance all make it tough. Scientists expect it might not be visible again until later this year, assuming it stays active enough. Even older telescopes and observatories are scrambling. Hubble has imaged ATLAS, JWST has targeted its coma, and ground telescopes are tracing gas emissions. Those upcoming observations may reveal cracks, jets, or surface irregularities that change the story entirely, if they're released in time. Transition, all of this leads us to the biggest question we can ask. After everything we've seen, we've walked through image anomalies, strange light behavior, odd composition, immense mass, trajectory puzzles, and speculative theories. Every piece pushes against what we believed comets could be. So here's what I want you to walk away with. 3I/ATLAS is testing our definitions. It's not simply a comet on a hyperbolic path. It might be a relic of a different kind of environment, a new class of interstellar traveler, or, yes, in the wildest hypotheses, something designed. But until strong evidence emerges, we don't claim it. We stay on the edge of curiosity. We wait for better close-ups, clearer data, sharper spectra, and we stay open to the possibility that the universe is wilder than we ever imagined. What do you think 3I/ATLAS is? Drop your theory in the comments. If you like this deep dive, hit like, subscribe, and let me know which cosmic mystery you want me to untangle next. Thanks for watching. Stay curious out there.